Higgs boson,
चंद्रशेखर लिमिट,
string theory,
न्यूट्रिनोस,
quantum entanglement.
कुछ समझा क्या?
Ever felt bored and confused while reading lengthy physics textbooks or articles?
Yeah, on God, bro.
I'm Arnav,
And I'm Pratham.
and welcome to Quark Talk, where we decode all the complexities and simplify these intricate concepts in physics.
They may have seemed too complex to understand until now.
So today we have a special guest on our show.
Please welcome Siddhant Ray, our classmate and fellow physics HL student.
Thanks for having me, guys. It's exciting to be here. I heard you've been diving into the Europa Clipper mission. It's such a cool topic.
So let's start by imagining a moon that's light years away from Earth and covered in a thick layer of ice. Underneath that ice, there's a vast, deep, and uncharted ocean.
It's like something out of a sci-fi movie, right?
Yeah.
Except it's real, and that moon is Europa, which is one of Jupiter's biggest mysteries. NASA's Europa Clipper mission has just launched, and it's setting out to explore that icy world and all of the secrets hiding beneath it.
Europa is fascinating because it challenges our understanding of where life could exist. We are used to thinking about planets in the habitable zone of a star, but here's a moon with a potential ocean far from the sun that might host the conditions for life.
Exactly. We're talking about a place that could have twice as much as water as all of Earth's oceans combined. And who knows, there could even be life down there.
Today, we'll uncover why Europa has scientists on the edge of their seats, what the Clippers mission will reveal, and why this could be the biggest step in the search for alien life.
And we'll also dive into how the Clipper is equipped to gather data, from mapping the icy crust to detecting potential signs of habitability. There's a lot to unpack here.
So let's first begin with Clipper's mission. Instead of orbiting Europa directly, the spacecraft is going to orbit Jupiter and make close flybys of Europa from 25 kilometers away. This strategy allows it to avoid getting overwhelmed by Jupiter's intense radiation belt.
Just 25 kilometers away? That's such a small distance, right?
Yeah, such a small distance.
But actually, it'll be like having a bird's eye view of Europa, allowing it to collect detailed data without lingering in dangerous areas for too long.
That's actually such a clever approach. Plus, the flybys will let the Clipper use its powerful instruments to study Europa's surface and subsurface. Think of it like a detective examining clues without stepping directly into harm's way.
That'll help us understand Europa's icy shell, its internal ocean, and whether its surface chemistry hints at habitability. So, scientists believe that under Europa's surface, there's a salty ocean, possibly twice the volume of all of Earth's oceans combined. And this is huge because, as we know, water is a key ingredient for life.
Europa's surface is also very distinct. I mean, like unlike other moons, it has very few impact craters, and it is comparatively much smoother than the other surfaces of moons that we have seen in our solar system as well. But what does that mean for us? It suggests that the surface is relatively young and that it's constantly being reshaped by some sort of geological activity.
Exactly. That resurfacing could be caused by pyrovolcanism, basically icy volcanoes, or cryovolcanism, basically icy volcanoes, or other forms of activity driven by tidal forces from Jupiter. The constant pulling and squeezing of Europa by Jupiter's gravity could create enough heat to maintain a liquid ocean beneath the ice.
And fewer craters usually mean that something is resurfacing the moon, likely from within. It's possible that warmer water from the subsurface ocean is welling up and breaking through the ice and also freezing on the surface. This kind of activity could be crucial in bringing nutrients and chemicals from the subsurface to the surface. And again, these are ingredients necessary for life.
And this resurfacing could also act like a conveyor belt, bringing material from the ocean below to Europa's surface. If life exists down there, this process might leave traces on the surface that the Clipper can detect.
Another unique feature of this is the network of cracks and ridges that covers the surface. Scientists think that they're formed by tidal forces. I mean, Europa's close proximity to Jupiter causes the moon to stretch and flex as it orbits, and this creates friction which creates heat, potentially keeping the ocean beneath from freezing solid.
Tidal heating is such a fascinating concept. Europa's orbit isn't perfectly circular, so its distance from Jupiter changes slightly, creating these intense gravitational forces. The same process could also drive the geological activity, reshaping the surface.
And here's another cool fact. Europa's icy surface is transparent in some places, which makes it easier to detect what's underneath. If there's organic material hiding there, the Clipper's instruments could potentially find it.
Of course, the Europa Clipper isn't just zipping straight to Jupiter, it's using gravity assist to get there. Kind of like a cosmic slingshot.
Right.
The gravity assist technique is genius. By using the gravitational pull of planets like Earth or Venus, the spacecraft gains speed without burning extra fuel. It's a brilliant way to extend the mission's capabilities.
Imagine if you could swing around a planet and get a speed boost without using any extra fuel. That's what the Clipper's doing, using Earth and other planets to gain the momentum it needs. It's a clever way to save fuel without while also carrying more like a larger amount of scientific instruments.
Yeah.
This is not only about efficiency but also precision.
What chemistry, absolute certainty,
Arey, you stop at all the measurements and uncertainties. I'm saying that a series of carefully timed maneuvers will guide the Clipper to arrive at just the right spots in Jupiter's orbit to begin its mission. This part of the mission is crucial, and everything needs to be precisely calculated. One tiny prediction error could possibly lead to the failure of the mission.
The maths and physics behind these maneuvers is incredible. It's a testament to how far human ingenuity has come in planning interplanetary missions.
And it's a long journey. It'll take several years to reach Jupiter. The spacecraft needs to survive in deep space, far from any sunlight, while keeping its instruments in perfect working order.
That's where the Clipper's robust design comes in. It's built to endure extreme conditions from deep space cold to Jupiter's intense radiation. Every system has been tested rigorously to ensure that it can handle the challenges ahead.
The Europa Clipper is like a floating lab, packed with high-tech instruments to probe Europa's secrets.
One of the key tools is the ice penetrating radar. It's designed to send radio waves through the ice and measure how they bounce back. It'll help them determine the thickness of the ice and the depth of the ocean below, kind of like taking an X-ray of Europa.
Another essential instrument is the magnetometer. It measures Europa's magnetic field, which is influenced by the salty liquid ocean beneath it. That way, the magnetic field shifts can give us clues about the ocean's depth and salinity.
And don't forget about the thermal imaging cameras. They'll map heat patterns on Europa's surface, which could reveal areas where the ice is thinner or where there's active geological activity like cryovolcanism.
And then there are the spectrometers. These instruments will look at the surface and the thin atmospheres above Europa, analyzing the chemical composition. If there are organic molecules like carbon-based compounds that are the building blocks of life, the Clipper spectrometers will be able to detect them.
And if Europa has plumes, which are basically like geysers of water vapor shooting out from the ice, the Clipper has a mass spectrometer ready to analyze them. These plumes might act as natural fountains, sampling the subsurface ocean for us.
Plumes are like windows into Europa's ocean. By flying through them, the Clipper can directly sample what's beneath the ice, giving us a rare glimpse into a potentially habitable environment.
And by studying these plumes, we could also get a sneak peek at what's inside the ocean without drilling through kilometers of ice. Like, why are we not landing on the surface though? Why are we only observing from far away if we could land on the surface?
It's all about protection here. So, Europa orbits deep within Jupiter's magnetic field, which is extremely strong. This magnetic field traps high energy particles, which creates intense radiation that could damage the spacecraft's electronics.
And as we said earlier, instead of doing all that, the Europa Clipper will just orbit Jupiter and make a series of targeted flybys, which in this way it minimizes exposure to the radiation while also collecting all the necessary data, right?
Yeah, it's like sticking your hand into fire for just a moment to grab something, then pulling it back out before it gets burned. It's painful, but sometimes worth it. These flybys will last only a short time, allowing the Clipper to gather as much information as possible while staying safe.
It's a brilliant compromise. By balancing close encounters with safe distances, the Clipper ensures it can carry out its mission without risking total failure.
The spacecraft is also heavily shielded, but that's not a perfect solution. By staying farther away and only making quick, focused passes, it can survive for a longer time in the harsh environment of space and the Jupiter system as a whole.
And this strategy also allows the Clipper to explore other areas around Jupiter. It can gather more comprehensive data about not just Europa but the entire system, making it a mission with wide-reaching implications for future exploration as well.
Absolutely. I totally agree with you, Pratham. The Clipper isn't just about Europa, it's a stepping stone for future missions to the outer solar system. The data it collects could guide us toward even more ambitious exploration, like landing on Europa someday.
The possibility of finding even microbial life would be one of the most significant discoveries in human history.
Yeah, basically aliens.
Yeah,
Or. Yeah.
extraterrestrials, whatever you want to call them.
Yeah.
So the Europa Clipper is basically our first step towards answering that enormous question of whether we are alone in this universe.
Like the Fermi paradox. I think we had put a poll on it later, like earlier.
Yeah.
So the data that Europa Clipper gathers won't just inform missions to Europa, but to other icy moons like Saturn's and Enceladus, which have similar features as well.
It's an exciting time for space exploration. With missions like this, we are pushing the boundaries of what we know and exploring places we once thought were impossible to reach.
It's a thrilling mission that's just getting started, but the potential impact is literally astronomical.
You and your dad jokes.
Yeah, I know, right? But please, they're too good, okay? So, seriously, the Europa Clipper has the potential to be the most significant exploration in human history.